Okay, so hyperbolas, they have similarities and differences to circles and ellipses. So your essential question is to compare and contrast the similarities and differences between circles, ellipses, and hyperbolas. Okay, they're still a foci, there's still a focal axis, there's still a center, there's still vertices, there's still standard form, there's still chords, but some new things, instead of major axis and minor axis, we have what's called a transverse axis. Transverse axis. The transverse axis is the chord line on the focal axis, connecting the vertices. Chord lying on the focal axis, connecting the vertices. The chord line on the focal axis, connecting the vertices. Okay, the other axis is the conjugate axis. So we have transverse axis and we have conjugate axis. Okay, this is a line segment length 2b that is perpendicular to the focal axis. Line segment length 2b that is perpendicular to the focal axis. Line segment 2b that's perpendicular to the focal axis and has center of the hyperbola as its midpoint. Has center of the hyperbola as its midpoint. The conjugate axis is the line segment length 2b that's perpendicular to the focal axis. Brian, have you written these down? Has center of the hyperbola is its midpoint. And then there's just the semis of both of those. So same kind of thing as these guys. We have a major axis and we have a semi-major, which is from the center to the vertice, half. So we have a semi-transverse axis. Can whoever's doing those mouth sounds stop, please? Okay, semi-transverse is labeled A. And the semi-conjugate and this even makes sense, is labeled B because we wrote in the conjugate that it's length 2b. So the semi-conjugate would be half of that, which is just 1b. Okay, can you put the phone away, please? Okay, we're going to draw a couple before we do an example, just so like we did over here, so using your colored pencils so you know what these look like. Take your ruler, please. And draw a coordinate plane. That's kind of not straight, is it? I was diagonal when I was doing that. Better? Yeah, that's better. Okay. The transverse axis is the chord line on the focal axis connecting the vertices. So the pictures we're going to draw are going to have a center at 0, 0, because those are the easier ones to start with. Center 0, 0. If the x-axis is your focal axis, then the transverse axis is the chord line on the focal axis connecting the vertices. So if we have like a vertex out here labeled negative A and a vertex out here labeled positive A, the chord connecting those is called the transverse axis. So it kind of is like the major axis because it's the wider side. The transverse is the wider side. So how long would semi-transverse be? Half. Yep, from one of the A's to the center. Okay, now the conjugate axis is perpendicular. It goes through the center, and it has a line segment linked to B. So make this one shorter. There's B and negative B. Make that shorter. Just shorter than A. And then take one of your colored pencils and connect them, a different color. And that is your conjugate axis. And it's perpendicular. So these two intersect at a 90-degree angle. The green one is your conjugate axis. And the semi-conjugate would be half the distance from the starting at the center extending to one of the vertices, B, or negative B. Okay, now unlike ellipses, when we had ellipses, we would just connect these with a nice oval. This time, we are going to connect them so it forms a rectangular box. Yep, like that. Dotted. The vertices of this box, if we connect the vertices of this box, we get asymptotes. What is an asymptote? An asymptote is a line the graph never crosses. If it's a horizontal asymptote, it never crosses at the ends. It's an end behavior. But these are diagonal asymptotes, so the graph never crosses. So I'm going to extend a diagonal asymptote from corner to corner of my box, trying to do it straight. You guys have rulers, so hopefully you can do it a little straighter than I did. Yeah, definitely in pencil. Got a little curvy. Okay, now we have two different types of hyperbolas. It depends who wins, where the focal axis is. In this case, the wide side of the box is horizontal, right? So in this case, X wins. So our hyperbolas will look like this. It has a vertice at that negative A, and it looks like a parabola that extends and comes microscopically close to this asymptote we drew, but never crosses the asymptote. And there's another one over here. At A, it's a parabola extending until it gets microscopically close to those asymptotes that we drew. This is the case where x wins because the focal axis, or the wide side of the box, is horizontal. X wins.
So the reason it wins is
It's the wider side. Okay? Versus, well, and then inside the parabola, just as before, inside the parabola will be our foci. It should be on the focal axis. Okay, now quickly we're going to draw it. Everything exactly the same, except for we're not going to put on the foci and the, well actually no, it's not completely the same because I'm rotating it. This time my focal axis is going to be the y-axis. Okay, if I put A, negative A down here, and positive A up here, we get our semi-transverse axis from the center. Extending to A is the transverse, semi-transverse, and the whole thing is the transverse axis. Okay, again, this is the transverse. It should be the chord from vertex to vertex along the focal axis. Okay, drawing B on the x-axis, it should be a shorter distance from the origin than A was. If we connect negative B to positive B, what's this axis? The which axis? Good, the conjugate axis. And half of it would be the semi-conjugate axis. Okay, after that, we draw vertical lines, dashed lines through B and A until we see the box forming. Horizontal through A, vertical to B until I'm even with A. And then through the diagonals of the box, we have asymptotes that the hyperbola will never cross. Through the diagonals of the box, that wasn't very straight. We have hyperbolas, or asymptotes that the hyperbola will never cross. This time, which way wins? What's the wider side? Is it the horizontal or the vertical spread? Vertical spread. So our hyperbola this time is different. We have a vertex on the focal axis here at negative A, and it gets microscopically close, infinitely close to our, what do you call those? Asymptotes. Okay, and same here. So you can see there's two different types of ones. Ones where X wins because it's the hyperbolas end up being horizontal, and the one where Y wins and the hyperbolas end up being vertical. Y wins. And somewhere in the parabola, which we can find mathematically exactly where it is, we have the foci. F2. Okay? Yeah.
does it really matter if which one is that one?
No. Okay, so the homework I'm giving you over the break is on ellipses. And when we come back, we will, don't lose these, please. We will be doing an assignment off of hyperbolas, but you should be able to at least answer some of the essential questions, similarities and differences of circles, hyperbolas, and ellipses. So the assignment that goes with this is in the honor section, H19, numbers 2 through 30 even. This is on your ellipses, okay? So it doesn't have hyperbolas on it. It's on ellipses. Oh, I can.
Right, because we're not supposed to have homework.